Okay, for today, it is a review day, and we graded the thing called Starter Quiz. I'm going to leave that in today's folder, which is the 16th. I'm leaving the key in there. Anybody who has missed that, you should go and grade that and drop it in the Dropbox in the graded condition with your score on the top. It's out of 10 points. You should take off 1 point for any problem you made a mistake on. I know that'll mean there's a minimum you would get right of 5 right out of 10. Oh, and you don't have to grade the very first problem because it was super easy. All right, so anyway, the second thing we did in class, this is for the kids in the video here, is we also graded the top 20. You gave yourself a score out of 20. That key is also sitting in Schoology. And last but not least, we are going to be grading or sketching tangent and 8 tangent of 4x. If you don't remember how to graph tangent, that's going to be a kind of a big deal because that was all I really tried to teach you yesterday was some of these new functions, tangent, secant, that kind of stuff. So if you forgot that there's asymptotes here and here, then you should make notes for yourself. Oh, you can't see this yet. Hold on just a second. I'm going to pause the video. All right, so this is what tangent looks like. This is pi over 2 and negative pi over 2. I've given up on trying to use my Apple Pencil for today. It seems to be non-functional. This is a 1. This is a negative 1. That's basic tangent. Raise your hand or your virtual hand if you feel like that would be a nice, easy R2. You could handle it. You're good on that. All right. Noticing only 2 people online raising your hand. How about if everybody just raises their hand online to make sure everybody's actually there? And you are. Oh, there's one monkey not raising their hand. I mean, the icon is a monkey, but anyway. There it is. Okay, good. All right, so now let's get to this one. That's more realistic R3 question. Graphing 8 tangent of 4x. Do you know how to change your labels? Because the graph will look basically the same. It's just the labeling that'll be different. So I won't ask how to do this part. I just showed you. This is pi over 2, negative pi over 2. Asymptotes I'll put in blue. Myung-Hai, can you tell me how to reflect the fact that there's an 8 there now instead of a 1?
That's an amplitude, so you change those 1 and negative 1 values into 8s.
You are correct, sir. Now, one thought. When it comes to tangent, we aren't going to ask you for the amplitude because the amplitude is normally the height of the wave. What's the height of this? It's infinite, so it's kind of hard to call it an amplitude. But that is the amplitude position, and it works. It just doesn't make much sense on tangent. It does make sense on a sine, cosine, or even a secant or cosecant. But when it gets to tangent, it gets so weird. Actually, secant and cosecant go on forever upwards also, so it's kind of hard to talk about how high the wave is. All right, so anyway, what else do we have to do with the 4? I hope you get, we are going to just multiply by 1/4 here and here. And that's going to turn them into pi over 8 and negative pi over 8. Put your virtual or real hands up if you had that one right. Yay, okay. Now let's just do one of the other kind. The other kind are secants and cosecants. Everybody graph regular cosecant. And I bet you a lot of people right now aren't graphing cosecant. What do you think they are graphing? Sine, very good. Because this one rides on the back of its sister function. So I'm going to put in asymptotes wherever it hits 0 because, you know, when you're 1 over that, you can't be 1 over 0. And then I'm going to put in some loops here and here. And I'm going to label these spots as negative 1 and 1. And this is 2 pi, pi, pi over 2, and 3 pi over 2. There is your classic cosecant graph And it'd be even better if I would just erase the red line so that I don't have that there anymore. We wouldn't want you to think that that's a part of the graph. It just helps you figure out where the asymptotes are. There, that is cosecant. Put your hand up if you generally agree, even though my sketch is a little rough. Okay, good. And now last but not least, we're going to do this one. Don't worry about the amplitude, period, etc. Just graph it for me. And yeah, there's some tweaks. So what I'm going to do first is I'm going to just copy down my original graph because it starts based on that. And instead of 1 and -1, I'm going to change that to 1/2 and -1/2. Instead of 2 pi and pi over 2, I'm going to adjust all of those. One of the hardest parts. Can somebody please tell me what to do to adjust my horizontal numbering? I'll take a volunteer. Yes, sir. I'm going to multiply by 1 over pi. You are correct. That's like dividing by pi, but I like it better because it works for fractions. Multiplying by 1 over pi. And the pi's will cancel then. This turns into 1/2, 2 halves. See what I did there? 3 halves, and 4 halves. I know they can simplify. But the beauty of numbering them as just 1, 2, 3, and 4 overwhelms the ability or the quality of, well, mine's reduced. Well, mine's nice and numerical. So I would accept it if you didn't reduce those. I know 2 over 2 is the same as 1. 4 over 2 is the same as 2. Now, one last thing. Pickett, what's the one last thing?
I believe it's that you have to flip the graph.
Why?
Because the 1/2 for the amplitude is negative.
That negative right there makes you flip the graph. I agree. This is going to be my final answer in black. And I'm going to erase out the original one that was in blue. And there we go. I know it's messy, but I think you got the idea. All right. And the next part is something we're doing kind of just for fun. I'm going to be talking about the true mirror and how it can show you what you really look like.